Hello, how are you? My name is Agustin. I work at the University of Buenos Aires. I presented this project 3 times in different small talk conferences, so some of you are very familiar with it. For those who are not, I will make a little introduction. My research is around teaching programming to children. In particular, I am focused on a didactic sequence I made that I will show today. And I work with this particular environment that I maintain. In this environment, you can, the children can make his own characters and well, can put it in this space and create rules to control the character and so on, create their own simulations. So the project now you can find it in this web page. In previous talks, I presented as another name. Now I rebrand it as Diálogo. And in this page, you can, well, download it. And here is the didactic sequence I prepared for children and teachers to use, and I will talk about it today. So the first class I showed to the children is to create this chess game, and they have to draw it completely, and then create a program to allow to move a piece. And the effect we want to create is that when the horse touches this piece should disappear. So for all the white pieces that go to the place where is a black piece, it has to disappear. This is a very simple program they have to build, and they have to construct, well, make all the drawings and define the idea of a black piece and white piece. And define these rules here. No, when a white piece touches a black piece, then the black piece should be removed, teleport to the black hole and disappear. So for this to work, they have to define a category. So first class is about creating categories, which are a form of creating ideas. In this language, I call them categories. In Smalltalk, they have the name of classes. In functional programming, we call them types. So for this to work, we have to create the category. So the first step for creating a category is to draw the category, and then to put all the pieces inside this category. With this combinator, you can put the black pieces inside the category. So I will make it so you can see it, how it works. So here I defined the category of all the black pieces. And then I will have to define the category of all the white pieces. And then when I have all this category finished, I can make the move. So here I was showing the developer space. And now I will go for the actual version that you can download. Well, here I have a lot of projects. Some of them belong to students. Here is one of them. This belongs to student. So let's say, well, let's move a little bit. So this is the right behavior. So this is the right behavior. This is the first class, and it's around categories. The second class, it's about another way to create ideas, which are not categories. And it is this is the second exercise. They have to create this little game, very familiar with some old cell phones like the Nokia. So this spider, this is not just but a spider, more like a cien pies in English. Well, so, and here are the rules. For instance, when the head of this spider touches this plant, then the plant is removed, and a new piece of the spider should appear in the place where this was. So it touches, and then appears another segment. No, another segment, etc. So here, when this touches himself, he has to lose. No? The game ends there. Well, there is a way to restart it. And these rules are about that. But if you see the rules, here there is a repeated pattern. Now, this one is removed, and this one appears in the place of this one. Here is the same. This one is removed, and this one appears in the place of this one. So the idea of the class, after they created the game, is to remove this repeated code and create a new abstraction, which is this one, the idea of transformation. This is an actual drawing of a children that made the workshop. And they have to create the abstraction and replace the repeated code with the new abstraction they have created. No? They have to, well, remove and bring the new abstraction in. And reuse it. Here. So they have also to define it this way. I have already defined it. So here the project will continue working as it was, and they created a new idea. Like in the first class, they created an idea with a category, and here they create an idea through a substitution. So I believe all languages have these two forms of abstractions, categories and substitutions, functions and types, classes and messages. And I try to focus the first two classes on these two main concepts that I believe are very central in programming. And a reflection I want to bring to you, it's about this, about what are the central notions of programming, and where do we have to focus if we have to present them to children. So in the first two classes, I present these two notions that I believe are at the core of modeling and creating abstractions. And well, after that, there are some other activities. For instance, they can do some metaprogramming, because in this language, the symbols and the elements can interact. And here, for instance, we have a rule where this character can push symbols. So to escape this room and enter to the next one, it can change this rule and then continue to the next level. This is another class where I introduce metaprogramming to children. Then I have shown some of these. Then I made them represent natural numbers and addition. I will not enter on this model. And at the end of the workshop, they can reuse the games they made. This is another game they made, and they can reuse the model of numbers within this game to add points to the game. So this is a Pac-Man with a C aspect. This is inspired in several things, but I propose them to inspire on the Connicet expedition to the bottom of the sea that was very popular here in Argentina. So some of them, well, it's very small, but this is the famous Estrella Culona. I don't know if you heard about that, Estrella Culona. So, well, this is more or less the games they can create. This is another game also made by children. And here in this class where the core is to control time, and through time the enemies throw arrows to the protagonist, to the ship, and this is the way the throwing of the arrows is controlled through a simulation within the simulation to manipulate time. So this is another class. If some of you is interested in trying this with your son, your daughter, or child in your family, there is a video for each class you can follow where I am there talking, playing a character I make, so to make it more fun for the children, maybe not for you, but for the children. And well, it's open for everyone to use, and I hope you to take advantage of it, try it, and give me feedback if you want. Well, as a next version, not the current version, but the next version will introduce some use of artificial intelligence to, sorry, not what I wanted to do. To introduce some extra elements to tune a little bit the drawings the children made, etc., etc. Now this is FutureWorks. I had to deal with something similar that Maxi presented, the use of an API to connect, in this case, OpenAI, and well, manage responses and requests, etc., different formats. But I'm not talking about implementation, but the feature I will add in the future work. So, well, this is the new element in this project, this didactic sequence. I wanted to present it to you. This is made in Smalltalk. It's quiz Smalltalk, and well, it's now for the public to download, use it, and also now you have a sequence to follow to teach. Thank you very much.
I have some questions. So the first one, well, thank you very much for the presentation. The first one is, have you tried with children? And if so, how was the result? And the second one is you talked about metaprogramming class. Could you be more specific about that, like with an example? Or why metaprogramming? Why did you want to teach that, and so on?
Well, two couple of questions. One, why do I use metaprogramming? I want to show the children that the program is something dynamic that can be is changeable, and it can even change while it runs, not only when we define it. So it's a more conceptual, if you consider as a notion, but I believe very important in programming. And well, since the program is defined by these rules, then if the program here, so what? So if the program which is now running, I am controlling the characters, the program running, and the program pushes something that changes the behavior, here there is a rule that says that this character cannot trespass this uh, this element here. Sorry. So since the character cannot trespass, cannot go to the other level. So when it it changes the program, so it can pass to the other level. And there are, well, some other levels to continue with different rules, etc. No? And the first question was?
The first was about if you tried with kids and how it worked out.
Well, I've been trying this project with children in different conditions. 2 years ago, I tried with in a classroom context at the University of Buenos Aires in a workshop open for the community. And in this case, I made a workshop online with these videos that are that are now open for the public. But in the when I opened people to participate, they were delivered through email. They were completing the project and sending me the classes, and I give them feedback, etc., etc. So that was the dynamic. When I ended the sequence, I publish it. I made it public in the website. So more or less 20 students made the workshop this year, and some of them are already sending me classes. And the idea is for those who finish the workshop to continue with this artificial intelligence feature in future classes I will make.
Okay, thanks.
Hello. I love the demos. I wanted to ask you something because I think all of the system is very like custom made, and I like that there are drawings from the children and so on. And I was a bit surprised that you decided to implement like the artificial intelligence feature to change the drawings. And so I want to ask you, like, why did you decide to implement that?
Well, it is a feature, as you said. I was trying to see what happens with it. Maybe in the examples I show, well, it is a little tuning of the same drawing, and you may think that this can disallow children to draw. I don't know if you're focusing on that, the question, but it's something I ask for myself. This will encourage children to draw more, or the other way around. So if it is the other way around, we may remove this feature. I don't have an answer yet for that, but the starting point of the project, it's always your drawing. You have to draw. Then you have to change your own drawing with artificial intelligence. But the first step of drawing, you have to do it. So there is no, at least now, way to skip that part. So every children, it doesn't matter if you are very good at drawing or not, you have to do that step. In one of the workshops I made, there was a girl that said to me, I don't like to draw. So I asked her, why do you like to draw? Everyone's like to draw. No, I don't like it. Inside myself, I said, well, maybe she feels it's not good on drawing. So with time, you tend to say, I don't like it because you're not good at it. So I said to her, well, don't worry. This is not about excellent drawings. It's about representing. The idea of the drawing is that you express yourself, create an idea, and try that. Try just to create a sketch and a schema of your idea. Well, the girl said, okay, and continue very well. So maybe this feature can encourage some people. Okay, you're not good at drawing. Don't worry. You will then tune it with AI. So you have to do your first step. Well, these things, I don't know. I don't have an answer, but there are things I care about, think about, and thank you for asking about that.
I have two small questions. One is, can you go back to the example you were showing earlier, the one with the burglar?
Which one?
The metaprogramming was the last one you opened.
This one.
No. The last one you opened.
The
It's
metaprogramming.
yes, that one. One question is, there you have like two kinds of rules, right? You have like you declare something as an element that moves, and then you have rules regarding how it moves. In general, how do you differentiate these kinds of rules?
How do I differentiate them?
Yeah, in the sense of, okay, I look at a program like this. How do I differentiate if a rule is when this happens, then do this, or for this behavior as okay, a movable element, configure the way the element can move, or is it just ad hoc and it's not meant to be generalized?
I don't understand quite the question. I will try. If someone can reinterpret it. There are different rules. Some of them are particular, and you can make them general by creating categories. This is the way to, like, well, like any other language, when you create categories, you make your substitutions more general. So here we have a rule that the children will create by pushing. Now, and the rule says when this character collisions with this element, then now this is not well created. This door will disappear, so it will behave like that. If we want this rule to be more general, we have to put this character on a category of all the characters of this game, for instance, and in that way put the new abstraction here, and every character that touches this kind of element will make the element disappear. So I'm sorry if I cannot
Okay,
answer
okay.
perfectly well your
Okay,
doubt.
and I have another question that was, how does this compare to like Asian sheets or other like earlier systems?
Which systems?
Asian sheet, or there are a few like similar rule-based graphical systems.
I don't know them.
Okay.
I can tell you that I inspired in this exercise from a video game called Baba Is You. In this video game, you have the characters and you have the rules, and the same. You can change the rules and pass to the next level. The difference is that here, all the language, it's there to be changed, all the language. And it's a language not only to simulate, but also to create abstract models like natural numbers, etc., etc. In the case of BOSU, it's a very more restricted language of the game.
Thank you.
Thank you very much.